Let's say we have 1 propanol and 2 propanol. What's the difference between these two molecules? The molecular formula is same, C3H8O, in this case to C3H8O. The chain length is same, that means the carbon skeleton. What we mean by carbon skeleton is the chain length or the parent chain. So what's the difference between 1 propanol and 2 propanol? The difference is the OH group attachment. In 2 propanol it is attached at 2 position. In 1 propanol it is attached at 1 position. That's the only difference. So the difference comes in the position of the functional group here in this case, and therefore these two molecules are position isomers. Okay, these two molecules are position isomers. Now let's say we have cyclopropanol. Is it possible to make a comparison between 1 propanol and cyclopropanol? No, we cannot, because here the molecular formula is C3H6O. It belongs to a different homologous series. Okay, not the same homologous series, a lower homologous series. Okay, so we cannot or we should not compare cyclopropanol with 1 propanol or 2 propanol. They both are alcohols, they are all alcohols, but when we talk about position isomerism, molecules with the same molecular formula. Okay, that means that same molecular formula obviously means that it belongs to a same homologous series, not to a lower or higher homologous series. This point you need to keep it in mind. Okay, and here in the definition, when we say unsaturated linkage, what we mean is double bond or triple bond. Okay, so let's discuss few more examples. Let us say we have these 3 molecules. Among these 3, which 2 are position isomers? So let us first find out the epoch names. Okay, so this is 1, 2, 3, 4. So this molecule is 1-chloro-butane, and here we have 2-chloro-2-methyl-propane, and here we have 1, 2, 3, 4 2-chloro-butane. So the chain length is same in 1 and 3, and therefore 1 and 3 are position isomers. The molecular formula also same, chain length is same. Okay, the molecular formula in all the 3 cases are C4H9Cl. Okay, so how about 1 and 2? So 1 and 3 we already mentioned that they are position isomers. How about 1 and 2? 1 and 2 are chain isomers, they are not position isomers, because the chain lengths are different. Remember the condition for position isomerism? Same molecular formula, same carbon skeleton, that means same parent chain. In 1 and 2 we do not have the same parent chain, we have 2 different parent chain. So if we are making a comparison between 1-chloro-butane and 2-chloro-2-methyl-propane, then we are talking about chain isomerism. and likewise 2 and 3 are also chain isomers. Okay. So, let us discuss one more example. So, here we have 1, 2, 3 trichlorobenzene, and here we have 1, 3, 4 trichlorobenzene, and here we have 1, 3, 5 trichlorobenzene. So, are these position isomers or ring chain isomers? They are not ring chain isomers, they are definitely position isomers, because the parent chain here is benzene, that is the parent chain, the parent carbon skeleton, and 2 of the substituents are attached at the same position 1 and 3. So, here also 1 and 3, here also 1 and 3, here also 1 and 3, and the difference comes in the position of one chlorine atom. Here it is 2, here it is 4, and here it is 5, and therefore, these 3 molecules are position isomers, they are not ring chain isomers. How about here? Feel free to pause the video and try to work it out yourself. How about 1 and 2? One and 2 are ring chain isomers. Why? Because the substituent is different. Here we have a ethyl substituent in 1, ethyl cyclopropane. In 2, 2 is 1, 2 dimethyl cyclopropane, and here we have a methyl substituent. Okay. Remember the condition once again, same molecular formula, same carbon skeleton, parent chain has to be the same, and the same substituent or functional group, not a different substituent and functional group. But here if we are comparing 1 and 2, we have 2 different substituents, even though the molecular formula is same and the carbon skeleton parent chain is same, but the substituents are different, and therefore 1 and 2 are not position isomers, 1 and 2 are ring chain isomers. How about 2 and 3? 2 and 3 are definitely position isomers, because now the difference comes in the position of the methyl group. 1 and 3 are ring chain isomers. So, you need to be careful when you are talking about position isomerism. You need to make sure that 3 things has to be same, molecular formula has to be same, carbon skeleton has to be the same, and then the substituent also has to be the same. Only the attachment of the substituent or the functional group or the double bond or triple bond has to be different. Okay. So, that point you need to keep it in mind. If you do like this video, consider subscribing it to Chem Media. Thank you.